In this session, let us try to explore the Hadoop ecosystem. The success of Hadoop framework has led to the development of an array of softwares. Hadoop, along with these set of related softwares, makes up the Hadoop ecosystem. The main purpose of these softwares is to enhance the functionality and increase the efficiency of Hadoop framework. The Hadoop ecosystem comprises of Apache Pig, Apache HBase, Apache Hive, Apache Scoop, Apache Flink, and Apache Zookeeper, along with the Hadoop distributed file system and the MapReduce. We all know the functionality provided by the Hadoop distributed file system and the MapReduce framework. Now let us try to explore the functionality offered by rest of these softwares. Let us begin with Apache Pig. Apache Pig is a scripting language used to write data analysis programs for large data sets that are present within the Hadoop cluster. This scripting language is called as Pig Latin. Apache HBase is a column-oriented database that allows reading and writing of data onto the HDFS on a real-time basis. Apache Hive is a SQL-like language which allows querying of data from HDFS. The SQL version of Hive is called as HiveQL. Apache Scoop is an application that is used to transfer data to and from Hadoop to any relational database management system. Apache Flink is an application that allows to move streaming data into the Hadoop cluster. A good example for streaming data would be the data that is being written to the log files. And finally, the Zookeeper takes care of all the coordination that is required among these softwares to function properly. This concludes our discussion on the topic Hadoop ecosystem.
So those are the different tools available in Hadoop ecosystem, but not only limited to that, there are several other tools also available under Hadoop ecosystem. So one such is Apache Kafka. So let us see about this Apache Kafka. It is the real-time events generated by smart objects are consumed into a processing engine. Messaging systems are designed to accept data or messages from sensors or log files and deliver it to stream processing engines such as Spark, Streaming or Storm. So these tools are used for logging. The Apache Kafka is a distributed publisher-subscriber messaging system that is built to be scalable and fast. It is composed of topics, message brokers, where producers write the data and consumers read the data from these topics. Okay, it is something like a broker where it performs publisher subscriber kind of model for exchanging of information. The publisher publishes the data and the subscriber takes the data. Due to distributed nature of Kafka, it can run in clustered configuration, can handle many producers and consumers simultaneously, so parallel processing can happen, and exchanges information between nodes which are parallelly connected, allowing topics to be distributed over multiple nodes. So information will be distributed among the multiple nodes. The goal of Kafka is to provide simple way to connect data sources and allow consumers to connect to that data in a way they would like. So this is the Apache Kafka data flow. So here is a producer, here is a consumer. So this is the Kafka cluster where message brokers are attached to topic and Kafka nodes are here. So as and when the messages are published, they will be consumed by the consumer. So consumers are like Spark, Storm, Hadoop, etc. To know more about this Kafka, let us watch a video.
Hi.
So now we're going to talk about why Apache Kafka. So let's take a very simple example. At first, you have a source system and you have a target system. This could be your website and your database. It's very simple at first. But then it gets very complicated because you have many source systems. You have your website, you have your email clients, and then you have many target systems. You have many databases, you have many different data stores that you want to store your data to. And it becomes quite complicated because you have to integrate every source system data with every target system data. And each integration is tedious, they don't have their own protocols, it's not really safe, and so on. So Apache Kafka comes in the middle. It helps you decouple your data streams. Basically, as an example, on the top we have all sources, website events, pricing data, financial transactions, or user interactions. And they will all publish the data to Apache Kafka. And then your databases, your analytics, your email systems, your audits, they can just take the data from Kafka and do whatever they want with it. But the thing is, there's a middle layer, Apache Kafka, which allow you to decouple your data streams. For your website events, they only worry about pushing data to Apache Kafka, and that's it. And for your database, they can just source any data from any source, just from Apache Kafka. So that's a very, very strong concept in here. So Apache Kafka, on top of decoupling, does a little bit more things. It is distributed with a resilient architecture and fault tolerant. That's because you have many servers. There's also something called horizontal scalability. That words basically mean that you can add servers and your system will scale as you add servers. It's also really high performance. Some latency is observed to be less than 10 milliseconds, so it's pretty much real time. And it's used by many, many firms. It was first created by LinkedIn, then open sourced, and today it's used by the biggest firm, so Netflix, Airbnb, Yahoo, Walmart, and I can't name them all. So a few use cases for Apache Kafka. You could use it as a messaging system. You can use it as an activity tracking tool. You could use it to gather metrics from many different locations. You could gather application logs. We can also do stream processing using what we'll see is the Kafka Streams API or Spark, for example. As we saw before, it allows you to decouple your systems, and it has many different integrations, and I just named a few. There's Spark, Flink, Storm, Hadoop, and other big data technologies. So Apache Kafka really solves big problems, and it's a really, really cool technology to know. It's up and coming nowadays, and many companies are already using it, so it's good that you learn that skill.
Okay, that is how the Apache Kafka works. Now let us see Apache Spark. Apache Spark is an in-memory distributed data analytics platform. It is a distributed data analytics platform. It is designed to accelerate processes in the Hadoop ecosystem, which enables it to run jobs quickly because it is having in-memory. At each stage of map reduce operation, the data is read and written back to the disk. It introduces little latency for each disk operation, reading the data and writing back to the memory. However, with Spark, the processing of this data moved into high-speed memory. It uses high-speed memory, so latency will be less. This speeds the batch processing jobs and also allows near real-time processing of events. Real-time processing is done by a component of Apache Spark project called Spark Streaming. Spark Streaming is an extension of Spark core responsible for taking live stream data from messaging system like Kafka. It takes the live stream data from Kafka, systems like Kafka, and dividing it into smaller micro batches. These micro batches are called discretized streams, or in short D streams. So these micro batches are called D streams. The Spark processing engine is able to operate on these smaller pieces of data, allowing subsequent actions. Due to this instant feedback, the capability of Spark is becoming an important component in many IoT deployments. Systems that control safety and security of personal time-sensitive processes in manufacturing space, infrastructure control, in traffic management, all benefit from these real-time streaming capabilities. So basically it is a streaming, it gives streaming functionality. So this is how this is the architecture of Spark. Spark can work standalone with only HDFS, or it can be accompanied by Yarn or MapReduce. So in different combinations the Spark can work. To know more about the Spark, let us watch a video.
Apache Spark is a fast and general engine for large-scale data processing. It is around 100 times faster than MapReduce using only RAM and around 10 times faster if using disk. It builds upon similar paradigms as MapReduce. It is well integrated with Hadoop as it can run on top of Yarn and can access HDFS. A cluster resource manager or resource manager is a software component which manages various resources such as memory, disk, CPU of machines connected in the cluster. Apache Spark can run on top of many cluster resource managers such as Yarn, Amazon EC2 or Mesos. If you don't have any resource manager yet, you can still use Apache Spark in standalone mode. Instead of building own file or data storages, Apache Spark made it possible to read from all kinds of third-party data sources, such as Hadoop Distributed File System, HBase, Hive, Tachyon, and Cassandra, and many more. Apache Spark comes with great set of libraries. First, data frames. Data frames provide a generic way to represent the data in tabular structure. The data frames make it possible to query data using R or SQL instead of writing tons of code. Streaming library makes it possible to process fast incoming streams of used data using Spark. MLlib is a very rich machine learning library. It provides very sophisticated algorithms which run in distributed fashion. GraphX makes it very simple to represent huge data as a graph. It provides library of algorithms to process graphs using many computers. Spark and its libraries can be used with Scala, Java, Python, R, and SQL. Only exception is GraphX, which can only be used with Scala and Java. With these set of libraries, it is possible to do ETL, machine learning, real-time data processing, and graph processing on big data using Apache Spark. We will cover each component in details as we go forward.
Okay, that is all about Apache Spark. So let us study about the other tools of Hadoop ecosystem, Apache Storm and Apache Flink. Apache Spark is often used for both the distributed streaming analytics and batch processing. So the Spark is used for both distributed streaming and batch processing. Apache Storm and Apache Flink are Hadoop ecosystem projects. They are designed for distributed stream processing mainly, and they are commonly deployed for IoT use cases. They can pull data from Kafka, which we have seen earlier, and process it in near real-time fashion. It will pull the data from Kafka and process it in real-time fashion. Storm is very fast. A benchmark clocked it at over 1 million pulses processed per second. per node. It is scalable, fault tolerant, and also guarantees your data will be processed. It guarantees that your data will be processed, and it is easy to set up and operate. So that is about the Apache Storm and Apache Flink. Okay, so let us study the remaining things in the next class. So that's all for today. Have a good day. Bye.